Okay, so welcome to this month's community meetup, where Johan and Lukas, about thesis students, will present what they've been working on. And we said also that if you have any questions, you can interrupt them or raise your hand and you will take them. So please take it away.
Yeah, okay. We have been writing our master thesis on the topic of aggregation with the title Improving Event Aggregation in Automation of Software Development Workflows. So starting up, what is so first the agenda. I'll start a short introduction, and then we'll talk a bit about how the aggregator works, possible new use cases with this tool, and then a summary in the end. So first off, what is the purpose of event aggregation? So with Eiffel, we create a lot of events which are connected. And it can be interesting to detect certain patterns among these events, like this. And then when we detect a pattern, we might want to send information and do something with it. For example, start a new test or upgrade the CLM level, for example. So what is the problem with the current aggregator, which is Eiffel Intelligence? But again, aggregation is a set of rules defining patterns and how these events should be combined to trigger a callback. This is the definition of our aggregation. And the current aggregation is inefficient, and the rules are difficult to write and requires new instances of Eiffel Intelligence for each aggregation rule or pattern. So what we are looking into is it possible to find and use readily available tools to solve this problem? And we have found that graph databases is a promising alternative, and specifically Neo4j. So what is Neo4j? I already said that it is a graph database, which means it stores data as a graph, which the image shows. And then we can store information on both the nodes and the edges of the graph. And for example, we probably want to store the link information from the Eiffel events on the edges and the rest on the node. And this graph structure enables efficient queries on connected data, which is what the Eiffel events are. So here we have a couple of patterns which are to us interesting to detect at Ericsson or just in general. I'm sure of this. And these are the artifact created pattern, artifact published, and CL reached. And then we also have a fourth pattern, which is not possible to do with the current Eiffel Intelligence solution, as this pattern requires us to do both upstream and downstream queries. And for this example, it means that if, for example, the CLM event is the most recent one, then we need to go upstream to the artifact created event and then go back downstream to artifact published and flow context defined. And this is not possible with Eiffel Intelligence. So the objective for this thesis has been to improve the usability, to make the creation of new subscriptions or patterns more intuitive, improve scalability to be able to reduce the number of active Eiffel Intelligence instances, and make the tool more flexible to enable new use cases.
Yes, so we have created a new aggregator using Neo4j, and we want to go into how have we created this new aggregator. So first of all, what should an aggregator do? An aggregator should be able to handle 3 external elements. So the input events themselves, aggregation rules, which are the user-defined patterns, as well as sending notification to consumers, which are the downstream systems to start, for example, a new test. And to be able to handle these external elements, we need to create internal components. So in this case, we need a receiver for input events. We need a preprocessor to process the events to have a better format for example, for Neo4j, we need to format them as nodes and edges. And then we need a detector to detect patterns. And then we need a notification system to send notifications to downstream components. And this is how a high-level architecture could look like. And we see that it's basically a sequence of components within our system to be able to handle all of these elements. So in order to create these internal components using Neo4j as part of our architecture, well, first of all, the receiver, we don't need a Neo4j for that. We can use a message bus to stream the data. Preprocessor, we use a script to format the events as links and nodes. And then we introduce these nodes and edges to Neo4j, where we use database trigger logics in order to achieve the detector component as well as notification. And this is how our high-level architecture look for Neo4j, or well, for the entire system, including Neo4j. And what is interesting about this is the whole graph database part of the architecture. So you might wonder, what is a trigger? Well, a trigger is something that exists in most types of databases, and it's something that automatically executes whenever updates happen in the database. So in our case, when a new event enters the database, we need the trigger to execute. So there are different steps that trigger need to do in order to achieve what we've previously mentioned it should be able to do, so detect and send notification. So these different steps are, well, as we just said, it needs to trigger on new events. The second step, it needs to find a pattern based on this newly inserted event. So if the newly inserted event fulfills a pattern, we want to go to step 3, which is sending a notification, including the information of the separate events that make up the pattern. And what's interesting about these steps, or well, what's most unintuitive is step 2, which is finding the pattern. And how do we find a pattern in a graph database? Well, we do queries. So this is a query of how a certain pattern could be found in a graph database. And it's very simple in the way that it works, because you simply draw out your different nodes and edges. And in this case, this is our artifact created pattern. So you can see very simply creating the nodes, edges, and then the third node to make up the pattern. And when we now have been able to create our queries or patterns, we're able to construct our triggers. And a trigger could look like this in Neo4j. And it might look very intimidating at first, but most of it is just generic code. And what a user needs to do in order to create their own trigger is just input these 3 fields. So the first field is just which type of event do you want the trigger to act upon. The second field is just which pattern do you want to find. And the third one is where do you want your notification to get to your endpoints. So the information flow itself, when creating all of these triggers for consumer, we can show a little example here. So if we have separate consumers, let's say we have 3 different ones, they want different patterns. So we create a unique trigger for each of them. And then when new event comes in, this new event gets checked against all of these triggers. So we see if this new event will fulfill a pattern for each of these consumers. And in this case, the purple person gets their notification because this new node fulfills that pattern. And this keeps on happening for each event that's introduced into the database. So yeah, what does this mean for an aggregator? Well, first of all, a new pattern, there's no need for a separate instance, active as it is in Eiffel Intelligence right now. It's also simple to create new patterns compared to the current solution. So it's easier for an engineer to create their aggregation rules and get the information they want. And throughout this master thesis we've done, we've also found some key findings. So we've tested the system, and validation-wise, we get the same output as Eiffel Intelligence, so we have a 100% accuracy. Scalability-wise, we see no effect on throughput when having a lot of data in the database. So we have tested up to about 45 million events and see no effect on throughput. So there's no need to have some kind of time to live for the data. And we've found one bottleneck, which is that the amount of triggers active will affect the throughput. But we're also looking into alternatives to be able to minimize this effect. So
yeah. And again, feel free to ask any questions throughout the presentation. But to the next part, some possible new use cases which we have been able to fulfill with this tool. So start off, we are able to handle much larger patterns than the current solution. So for example, this is a pattern which attempts to describe the entire pipeline in like sort of a dream scenario. And what to do here is we backtrack from a specified event, which is the end last event of a pipeline, so for something related to the product, and backtracking from it, we're able to see the different which builds up this, including all the different source code changes from in the beginning. So if you have an error in a product, you can see which different code can could it be that causes error. And this also allows us to give different insights about the status of the pipeline, how far have we come so far. And how this query can look is you can see to the right corner, I think, lower the right corner, and it's still not that complicated, even though this is rather large. And then we also attempt to modify this slightly and use it on real Eiffel events from Ericsson to aggregate the pipelines. And for this data, we had a bunch of very small pipelines which are connected with previous versions, and then it can look something like this. I also mentioned that the pattern to the left here is impossible with the current solution, but doing this sort of patternization is not an issue with Neo4j, as we simply just need to describe how does this graph look with the Cypher query, and then we can find it without any real limitations if we can describe it. But this pattern is a little bit unique because both the CLM and artifact published event can be the last event which sort of finishes the patterns and make it complete, which is why we need to have two separate descriptions because there can be different start events for the pattern.
And you've added all the event fields as possible attributes usable from these queries, I suppose.
We have not added all attributes, but we have tested with a couple of ones such as ID and product version. But you could easily squish the JSON object further to enable more attributes to be filter more attributes. So we could do this, but we just haven't because we thought we have showed the possibility.
Yep, gotcha. Thanks.
Yeah, and as a little summary, first of all, a user with this kind of system is able to create triggers in a user-friendly and easy way. With this system, there's also no need for separate instances, as everything can be handled in one instance of a database. And lastly, we're able to centralize use cases, so we can both use it as an aggregator for aggregating different patterns using the trigger logic, as well as doing analytics on larger patterns. So, larger pipelines, for example, aggregating pipelines. Well, yeah, that's pretty much what we have done so far. Do you have any questions?
I think this is super interesting. But if you don't, I mean, it's if you would use this as your main event repository, it would be pretty obvious. I think in our case, we would not want to do that kind of migration, but rather use it more for this kind of query ability, because we are lacking an ability to act on sequences of events. So in some cases, we hand code it, and that's not super difficult, but it's nice to not have to do it. So I think it would be something we would want to use, but then limit to only have like a sliding window of the past a certain number of weeks events, for example, and maybe not include all event types, which would of course restrict what kind of queries you could make, but it could still be quite useful.
If you only want to use it as this kind of aggregator part, only caring about recent events, that's no problem as well.
Yeah, I mean, would you just have a periodic deletion query, I suppose?
Yeah, exactly.
What kind of insertion performance do you get? Have you measured that?
You mean like throughput we get when inserting events?
Yes.
So on our hardware, we can handle about, when we have only one trigger active, we can get about 2,000 events a second, between 1 and 2,000. But then it gradually decreases as you increase the amount of triggers you have active.
And we have some estimates of how this degrades, but we will have more data for our report, which we're currently testing right now.
That's going to be 2,000 per second is totally fine. That's more than what we need.
Yeah. But when did we reached about 40 events per second when we had about how many?
I think about 400 triggers active, then it starts to get pretty slow. I think what we have reached for or try to achieve is to have as many triggers active when while still having throughput about 40 events per second. And I think we've been able to achieve about 400 triggers active at the same time, which is not too much, but there are other alternatives we're looking into to make the effect of the trigger less prominent. And I think we have some solutions that we're not going to implement ourselves, but maybe for future work, for example, somebody could look into how other alternatives could work.
And this has been a community edition of Neo4j, or?
Yeah. Exactly.
Okay.
And you're running on it is it's a virtual machine with 8 cores, 64 gigabyte RAM, 500 megs hard gigs hard drive.
Exactly.
That will probably give you some kind of indication on what the performance is.
Yeah, like a 2-year-old laptop, basically.
I would think it's better than it is faster than our laptops. It's a virtual desktop instance.
64 gig RAM you don't have in a laptop.
No.
No, I'm kidding a little bit, but I mean it's okay. It's okay. Yeah, that's very good. Yeah, excellent.
But then also, if you buy the, I shouldn't really promote the enterprise license. Sorry, that's an open source, but just be aware that they have support for other things, and you can also run it on a Kubernetes clusters. We have it inside Ericsson where they do that, so I would expect that you could maybe scale a little bit more, but we haven't been able to test that, how it works on Kubernetes clusters and scaling and so on. Yeah, but that's probably possible. But then a reflection, as you said, with having this as a main database, I doubt that we would have it either, because I think that the amount of triggers would be a limiting factor. So I would suspect that we would have, if we implemented when we do, hopefully, we would probably have more than just one instance to contract the amount of triggers. I think. Fredrik.
Yes, yeah, I just wanted to add that we spoke this Tuesday, and we have the setup you presented. As I said to you this Tuesday, that the only thing we don't have is the triggers on the Neo4j database, but we use Neo4j as the primary data source, and but we have the other way around, that we have triggers on the bus and in our Elasticsearch. But we give some weight to your work or thesis is that we actually have the setup you have presented. I don't know the throughput because I'm not in the infrastructure team, but we also have a lot of events going into Neo4j all the time. So for us, at least, it seems to work pretty well. We don't duplicate data in a secondary database or something, but we store it to Neo4j and we query Neo4j.
Fredrik Friset. I guess you.
Yeah. So I have a question on, because since we're not using it, this type of triggering this way at Access, I'm kind of curious about the general use case. Who is the actor or person that defines these triggers and makes them happen? Is it the infrastructure team, or is it the users, or who defines the triggers in a more real world use case, so to speak?
The developer, I would say. In our case, we use it for triggering an uplift of the integration of a higher level product, let's say, high level component. We trigger the update of that component based on deliveries on the upstream included products, so to say, included components, subcomponents. So
Okay.
as soon as someone has delivered something, there is an artifact created event and possibly a conference level modified event sent, and then the downstream integrator team or whatever component that integrates it could automatically trigger on that.
But I guess it's the kind of like a team that is setting up the pipelines that would do that integration, not the developer writing the code for the end product. Or
I mean, the developer is in charge of the dependency update configuration itself. So yes, the developer would do it. Yeah, at least in our case, it's the developer themselves who has it in there as part of their source code right now. The
Okay.
dependency trigger, dependency update trigger. But yeah, depends on how you say that.
So basically, the people that define the triggers don't really care about or know about how Neo4j works, or that the trigger is actually a Neo4j trigger. It's just something that they just want to aggregate events.
Yeah, they care about the information, of course. They
Yeah.
don't care about what system it is, but of course, they need to abide to the syntax of the system used.
Yeah, of course. But I was just thinking that then that there can be quite a lot of triggers quite fast if we let this go in a development organization. So
Exactly.
400 is not. It's kind of limiting, I would say.
Might be
in that sense.
Yeah.
Depending on how large your organization is, of course, but then again, if it's in the hands of somebody that doesn't understand the entire infrastructure, then you could easily have somebody create 10 or 15 triggers just to fiddle around with things and try things and don't really know how it affects.
Yes, so you need to guard that somehow, of course. Yeah. And there were solutions as well on speeding it up with splitting the trigger and the aggregation logic in different parts.
I can see now my screen went
So
black.
there are some ideas there that.
Let's see. We have some ideas to split up the different steps of how this kind of trigger logic works. So the problem right now is that we have so many triggers. So each event, even if it's some unrelated event, it will be checked against all 400 triggers. But it's possible to split up the filtering of nodes, for example, into a separate trigger and then have different procedures doing the querying and the notification itself. So it's possible to reduce redundancies in order to achieve a higher number of triggers active without degrading the system. But we have not yet tested this kind of solution yet, so we don't know how well it would actually be.
Okay.
And is there a way to use something other than webhooks for notifying of these things? Or alternatively, what is the behavior of the webhook when the receiving endpoint is unavailable?
You mean like if you go to the where you have the
Configuration of the complete.
you had that
You mean this one?
there.
So we have not looked into alternatives to using like API endpoints, but if the endpoint is not available, basically and nothing happens.
Okay, so there is
No
no retries or anything.
No.
Okay.
I guess if you want retries, I guess it would be possible to implement, but I think in general it would be better not to try.
And what's included in the payload? Obviously the triggering event, but what else?
So you mean the payload to the endpoint?
Yeah.
So that's something that the user could choose themselves. We chose not to highlight that right here. You can see on 2 lines below the last red box, we have a convert to JSON function, which is basically the request. And we only send the IDs of the nodes included within the pattern. But a user could choose to combine information however they want. That's included in the pattern, of course.
Yeah, it looks good. Yeah, very cool.
I should probably point out that maybe not the whole syntax here, but at least the search syntax is called Cypher.
Yeah.
And there are other databases that use the Cypher, and it's actually a separate language, right?
Separate language?
Or you can it's something.
Yeah, it's sort of a SQL alternative for databases.
So it's Neo4j created it, but it's gotten adopted to many other databases as well.
Any more questions or thoughts from anybody?
I have a last question. I don't know if you said it in the beginning, but the reason for choosing Neo4j, was that because you already have it active, or was there any reason why you chose Neo4j?
Basically because it is the market leading graph database, and we have as a part of our thesis that it could be interesting to also check for other graph databases, because what we have seen here is just that a graph database seems like a very promising alternative. So there are others which also could be nice. We have tested one other called memgraph, but it has it's a so-called in-memory graph database. So we have some storage issues with that one.
And I think it's also worth noting that when we started this thesis, we didn't go into graph databases, or we didn't get pushed into graph databases at all. And we've checked other kinds of solutions to create an aggregator, but within the process of trying to find good tools, we came across graph databases and found that its use case could be included as an aggregator. And that's kind of where we've landed.
So we tried complex event processing as well.
Yeah, exactly. So complex event processing we tried, and it didn't work very well.
So that is Flink, Apache Flink, the Ceph library there you tried. But that was a bit complicated. If you want more details, I guess you could read the report.
Or ask us, so that works too.
it feels a little bit silly to have a sort of a real database and store lots of events that you know you will never use. I mean, you can probably figure that out if you analyze the queries that are included with this. You can probably figure out what type of things you need to store at all. So it's a little bit disappointing that just a stream processor that caches events as needed it isn't available. I'm surprised.
Yeah,
It's a more
I guess.
difficult problem than I thought.
Yeah. If you go to the public one, or maybe one of the patterns, you can just shortly describe, if you can, out of your head, describe what the problem you.
When we get a new Flink event, we will start trying to match a new event into Flink. We will start trying to match this to a pattern, and that's all good. And we start one process to handle this. Then when we get a second event, which starts to, which will be like the next part of this pattern, then we will have two processes up now. One which is the previous single event, which is sorted, and then the combination of two events for one pattern. And then when we get a third, which also perhaps matches both, then we will quickly get 4 instances up, and we'll just not remove the previous started patterns. So we will just start to have a lot of different processes in memory, and we run out of RAM very quickly. And we tried to fix this by sort of limiting the time to live, but this needed to be very short to be able to function.
And also, you need to, when you're doing these type of things, you also need to consider in the order the events received. So take a look at the artifact published second one there. You need also then your logic to consider if, for example, the which FCD comes first, because it's you have to know which one it is. So if you're getting a little more complex pattern, it's a lot of headache. You need to think of.
Yeah, so if we get, if we take an example of this artifact published pattern, if we get an FCD event as input, it starts the process of trying to use the FCD as this one, but it also creates another instance of the pattern where the FCD could be this one. So we get kind of an exponential growth of instances active trying to match patterns as we get more nodes, because a certain node could be a part of many different patterns or parts of a pattern.
When we have these 3 patterns, which are the ones I showed previously, we get one start FCD event, which starts or are part of all the 3 patterns. Then we get second, and since this pattern in the middle can consist of 2. We have 2 FCD events. If we sort of build on top of the other one, the previous one. So that's why we get 2 new events, and as we get more events, it starts to build up faster and faster. And they won't disappear unless you tell them to explicitly, or we didn't find a way to do this in a good way.
The sequence of events, the order of events means that we need to create all these different.
Yeah, exactly. If you knew the exact order of the events, then you can have this much more limited, and it could be a good solution, I guess.
But I guess you have some kind of conditions on FCD1 and FCD2.
Do we have the code? Do we want to show how this looks?
Do you want to go that deep, Magnus?
I don't know if we need to go into the code, but
yeah,
if you would,
you can imagine
somehow
it's sort of a tree, which is, if we get this event, then we build we progress the pattern in this way, and if we get this other event, we progress it in another way. So it's basically a few if statements.
Mm-hmm.
And also know that when your professor, who's examiner for the thesis, when he saw this, he recognized the problem. And it was like, yeah, this is what I did when I did a master thesis. So it's kind of like it would be a master thesis of itself. There.
But you don't care about the order of the FCDs. It doesn't matter, because when you receive an Art C that's potentially interesting, you could then check whether it has links to any of those events. And if it doesn't, you can just discard that event. Same thing with the Art P, which probably has conditions. The Art P you are interested in, that should be the trigger for the whole thing, would be dependent on whether there's an Art C, whether it links to an Art C that has been previously marked as interesting, for example, because the identity matches something that we're interested in. And if you get the Art P and it does link to an Art C you find interesting, you could check if that links to an interesting FCD1 or FCD2. So that's sort of how I've been hand coding this stuff. And it seems like it shouldn't be possible to make it more generic than that. And that doesn't result, as far as I can tell, in an explosion of combinations. But it does require that you have, conditions here and there. I guess in reality, that's something you would have, I suppose.
Yeah, we do have limitations on it only progresses a pattern if the events are connected by the links, which is what you just described, I think. But still, if an event progresses like multiple patterns, so if it links to multiple previous events, then it will still create multiple new instances of this pattern. And well, for our data, we saw this explosion in instances.
But when you say instances, would that be what's the process in this kind? Is it an internal Flink concept or?
No, yes. So basically, we need to keep track of all the different patterns which we have started to work on. And as we start a new one, so it's basically different patterns which we need to keep track of. That's what I meant by that.
So one instance is a pattern which is not yet fulfilled.
Mm-hmm. Yeah, I'm not entirely convinced that it's necessary to do that.
So one, maybe not an answer to that question, but one of the things I can reflect on this when you were doing it, I know you were digging into this with Flink, and you were looking in Eiffel, and it felt like you had to struggle quite a lot to just get something up and running, whereas Lukas was kind of getting the whole thing up and writing queries directly. For usability reasons, I would still ask for getting a database. Even I understand you, Magnus, with the fact that you need something that big. So I think the golden solution that would be if you can write a query in Cypher and then have some tool that automatically translates that down to Flink code. That would be probably the most best thing. But we haven't really found anything like that.
No, exactly. That's what I have. I don't want to hand code this. I would like to write a Cypher query or something similar without having the whole database. That kind of stream processor, which is, again, what I find it surprising that it doesn't exist.
And then also one of the things maybe that was kind of like a decision when we also stopped with Flink was that we didn't feel that we needed this really high, real-time processing. Flink is built to respond with a lot of events in and really keep up the tempo. Whereas we felt that it was okay with kind of like a delay when we were doing our flow, so we didn't feel the real high performance, because if we would need that high performance, we probably had continuous Flink, because I think that one can actually handle more on high performance if you're able to optimize it good. So that was kind of also consideration. We had to choose when we went into the database part instead. There, but I understand you, Magnus, with having a database for this case is maybe a little bit too much, but that's what we ended up with.
Yeah, I mean, it's definitely easier to do.
Mm.
Especially when you already have the query language.
Mm.
But yeah, as I said, we do have hand-rolled implementations of this, and some of them could definitely be replaced with something based on Neo4j. Whether it's worthwhile to do that replacement now is probably not, but for future similar efforts, we could totally use this. So do you have a preprocessor or a filter? What does it do? Is it more like translation from the JSON representation of the event to the
Yeah,
basically
exactly.
a Neo4j API call, more or less?
Let's see here if I can find these. Yeah, so basically what we do is we process the JSON objects to just be nodes and edges before inserting them into the database. And what we're doing also in order to achieve some kind of higher performance with the system is utilizing multiprocessing. So by utilizing multiprocessing in our preprocessor, we can insert a lot more events per second. But we might also introduce events into the database before their dependencies or links are inserted. So in order to always achieve acidity or the right structure in the database to never get certain events before others, we query the database before inserting to see that all of the edges are already, the links already exist before inserting a new event. So we do that kind of process also.
But you have seen that you could actually, there is some kind of direct interface into Neo4j from, I think it was from Kafka, right?
I think so. I don't remember. I think right now we're using RabbitMQ, but if we were to use Kafka, I think, yeah, as you said, you can stream it directly into Neo4j.
But I guess also in the preprocessor, you also decide which attributes to put on the node. So you kind of select out the ID and so on, and put it on the node. So that is also done in the preprocessor, right?
Yeah, so we flatten the JSON objective and then keep the rest of the information, which is not as important to us right now as just a bigger blob, which I also can access, but with a bit more work.
But I think that kind of processing could also be done without our slow Python pre-processing scripts. And in this case, this kind of script might be some bottleneck, but using these kinds of scripts also, well, we achieve quite high throughput either way, so we haven't gone in the way of optimizing that part.
So any more questions?
No, I'm out.
No. Thank you very much for all your questions. It's been good discussions. So if there weren't any more questions or anybody else want to add something in or comments? No, all right, no. Then thank you everybody for joining. And we'll most likely not meet again in this constellation before the summer, because the next one is colliding with the midsummer week vacation, so it will be somewhat after summer. And then also, as you probably know, we have the Eiffel Summit 7th to 8th of October to look forward to in Gothenburg. So thank you everybody for joining, and see you around.
Thank you.
Thanks. Bye.
Thank you. Bye.